In SolidWorks Professional 2012, there's a fantastic new costing module to help ease the burden of calculating the costs of sheet metal and simple machine components. Let's start by taking a look at a sheet metal part. On the Evaluate tab, we now have a new costing button. As SolidWorks realises this part is sheet metal, that's the only choice we get for generating the costing. And we can see SolidWorks has instantly calculated the cost of this component. The costs come from a template. We can choose from different templates, maybe if we're going to use a different manufacturing process, or perhaps we use different subcontractors that each have their own costing methods. We can then choose from different materials, instantly seeing how each one will affect the cost. We can also change the thickness. You'll see that SolidWorks has chosen to start off with the same thickness as the part has been modelled with, but we could choose a different thickness to see how that will impact on the cost. The raw materials are calculated from the bounding box that SolidWorks calculates from the flat pattern. We could increase the size of this by using an offset, or we could enter our own custom area as well. We now have a new costing manager over on the left hand side of the screen, and here we can see a breakdown of all the costs. One important thing to mention with the costing module is that it isn't based on SolidWorks features, so we would have all this same information with imported geometry as well. So looking at the breakdown, we have some initial setup costs that would always be there for any part. Then SolidWorks has calculated all the individual cut paths for each of the features, and we can see those highlighted on screen. We've then got the bends, and in this case we have no library features, and finally we can add some custom operations, like in this case the part needs to be powder coated. Those costs all come from the template, so if we take a quick look at the template editor, we'll see how easy it is to set up. The first thing we'd specify is our currency. We then have our setup costs, the different materials that we want to allow people to choose, and the different thicknesses for each one of those different materials. Then we have our manufacturing processes. So in this case we have 3 different machines that can be used to create the cuts. And we then have a long list of the costs for each of those different thicknesses of material on each of the 3 machines. We can quickly cut down that list by choosing different machines, or only looking at certain materials or certain thicknesses. And we've then got similar information for the bends, library features, and any custom features that we want people to be able to add to the costing of the components as well. If we wanted to see the impact of choosing a different machine, we can just right click on any of the features and choose a different machine. So in this case, using a water jet to cut the original profile would be significantly more expensive than the original laser that was the default. Another thing that costing allows us to do, similar to Sustainability Express, is to compare our original design to changes that we might made. So once we've set up our original costing correctly, we can set it as the baseline. Now we can go and make some changes to our component and instantly see how they'll affect the cost. In this case we want to replace the 2 large holes that are cut out of the sides with formed features. Very quickly we can see that we've actually reduced the cost of this component by 8%, and if we want to see what's changed we can go to our breakdown, and we can see now that the cutting costs have been reduced, and we have the 2 new features which are actually cheaper than the cut would have been. So having reduced the cost of our component, if we now want to document that so that everybody can see it, we can generate a report. Again, the report's very similar to that used by Sustainability Express. So here in Microsoft Word we can see the end result. This is our final design, summarising the savings that have been made from the original, and on the subsequent sheets we can see the cost breakdown by feature, detailing the machines chosen, any custom operations, and finally we get the original design so that we can see our comparison. Let's now take a look at a machined example. Again, SolidWorks instantly calculates the cost for this component based on our default template. Again, we could choose a different template depending on where the part's going to be manufactured. We can choose from different grades and different types of material. This time you'll see that SolidWorks has calculated a three-dimensional bounding box for the original stock body. And over on the left-hand side of the screen in our costing manager, we can see a summary of the different operations and costs associated with them. If we look at the milling operations, initially we only have the one pocket. If I chose to use a slightly larger stock, maybe add 2 mm to the front face, we get a preview on screen and we'll see that SolidWorks has now automatically added a facing operation because of that extra material. Again, we can choose to set this as our baseline and then make some changes to our design to see how it impacts the cost. And in just a few seconds we get the new cost for our design changes. Again, we just want to add the 2 mm to the front face, and we can see that adding all these new pockets to our design has increased the cost of the component by 17%. Again, we have the ability to generate reports as Word documents, and let's just quickly take a look at the template to see where the costs have come from. Again, we have similar information for the basic setup, such as currencies and labour rates. But for machining we now have additional information for the different categories of operations, such as milling. So we can see for the different grades of material, on different machines we may choose to do it on, for the different depths, we have all of the information required by the equation to calculate the machining costs and labour rates. We can also choose to add additional operations, such as reaming, tapping, or finishing of a pocket, to give us an accurate costing for our machine component. Finally, back at the assembly level, we can now utilise the costs that have been calculated either in a bill of materials or here in the assembly visualization tool. So we now get a summary of the costs of each of the components, and we can very quickly visualize the most expensive, so we know where to focus our efforts with any cost reducing exercises.